Let's see. Just normally, what I've written here is about what we are discussing earlier. That's also I'm going to go with the small things. Look at here, guys. We have discussed about OSI layer, but we use TCP IP layer only. Use TCP IP only. Okay. We don't use protocol suite, TCP IP protocol suite only we are using. Okay. So a lot of people think because after learning of OSI layer, you are using TCP IP. People think you are using because of TCP IP new one. You are using TCP. No, guys, TCP IP came earlier than OSI. OSI is used to understand the way of network functionality and to create any new network, troubleshooting a network related issues. OSI layer is layer wise, it is useful. A TCP to OSI differences are also will tell, because again, if I told another time, it is a tough time it will take. Okay. In OSI layer, so you know the layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. These are the 7 layers of OSI model. No, in TCP we have only application layer. Okay, for these first 3 layers, what are the OSI layer? 3 layers do the same 3 layers duty is done by only one single application layer only. So in TCP IP, one single application layer, representation of OSI layer, application, presentation, and session layer. Of course, we don't have any coloring part is there, very good. So we'll try. Can color something in a different manner like this. Okay. It's not text color, it is background color, no problem. Transport is transport, no difference. As it, what is the transport part? That transport part is same thing only. Network layer we call it as a internet layer. Guys, if you search in a Google, it may give you different type of answers, but still it is my answer is most textbook answer it is. So data link layer and network layer, we combined it is a network access layer. Okay, 4 layers: application layer, transport layer, internet layer, network access layer. What is this? Latif Singh present. Earlier it is not present. Here present. Okay, so please check. Okay, if I use some lighter colors, it is good. Visibility is there. Okay, this is also, it is too much dark color. So blue, light blue. No. This is a blue, and this is, you can better to take this color. Okay. Transport layer. Just for our understanding, these 3 combination, these things, so like equivalent type. Okay, I think so. You can able to see the letters. Okay, otherwise you can bold it, no problem. Okay, guys. This TCP/IP model also called as DoD model because it's actually developed in the defense. It is actually developed in the defense. So that's why it is a DoD model. Okay, we are all using a TCP/IP model only. We are not using OSI model. Okay, and we are all using a IP addresses, not any addresses. We are all using IP addresses. That too, mainly IPv4 we are using, not IPv6 or anything. So main is important is IPv4. Okay, in specific conditions means specific networks like depends upon network internet service providers in certain countries, certain private networks, we are using IPv6, but globally IPv4. So main communication is IPv4 only. IPv6 is still, it is not completely worldwide updated. Okay, we are all using star topologies. Okay, we are all using star topologies. Topology, star topology we are using. Okay, so we are using TCP IP protocol suite for network communication, and that one IP address either IPv4, IPv6, mainly IPv4, and star topologies only we are using. So that's the point I want to try. Guys, next one is, so I want to talk about what is an IP address. IP address, we are already seeing what is an IP address and other things. IP address is a logical address. What is an IP address? It's a logical address. Okay, IP address is a uniquely identified device in the network. Okay, IP address can change according to the network. IP address is not a unique address, but it is uniquely identified device in the network. To communicate in network, to communicate in the network, devices need IP address to send, and receive data, packets, or like that, anything. Okay, so devices need an IP address to communicate in the network. So whether whatever you are they're sending or receiving, your device must have an IP address. Okay, guys, just I'm trying to draw something which is you already know. Yeah, there's another one. It is like generally, so we are connecting to a switch or a hub, right? So that's what I'm trying to say. Yes, I have a computer, PCA, PCB, so I have an IP address, and this is also having some IP address. Just for an example to understand, guys, if you see there is some part is same, but some part is different. Okay. So it is uniquely identifying a device in the network. So we can understand these are all belongs to a same network. Once you learn about network or not kind of stuff, that is I will tell, don't worry. But every IP address, every device, their NIC having an IP address. You want to communicate from one device to another device. For example, from PCA to PCB, I want to send a ping request. How to send destination IP address. Without IP address, you can't communicate in the network. This is what I'm trying to say. Okay, you want to send a ping request from PCA, of course, from PCA at PCA. So I'm putting at PCA. That is came into this position. Okay, this is simply thing about a IP address. Everybody knows what is IP address and MAC address differences, but I'm just giving small information about that one also, because do not forget these things, guys, because it's a very small things. Smaller are always important, not a very big concept. Like no one will ask you how to configure a switch or a router, what is routing protocols, explain routing protocols, that kind of stuff no one will ask you. Okay, what are the most possible questions are very basic. What is a MAC address? What is an IP address? How to check IP address? How to check MAC address? Kind of stuff. So this is part I also I will remove. Like this. Guys, simple points. IP address is a logical address and MAC address is a physical address. We can change my IP address, we cannot change MAC address because it is a fixed address. Okay, it is on fixed, it is a fixed on a NIC, network interface card. It is fixed on NIC, network interface card. Okay. Okay, so in IP address, we have a private IP, public IP address. Here, no private, no public kind of stuff. It is a fixed on a NIC. Okay. The next one is we use it for communication. This is a blurred, guys. In IPv4, okay, IPv4 version is there, that is 32-bit. IPv6 version is there, that is 128. In a MAC address, we don't have any versions. So simply we have a 48-bit that is represented in 12 hexadecimal. We already know, that's why I'm telling like this. Okay. So we are communicating with the IP address and compulsory, guys, that is all communications by IP address only. Madam, room all communications by IP address only. Okay, guys. So of course there is a few more things like a example how IPv4 is look like, how IPv6 is look like. That also you can tell. Like a example of IPv4 is, for example, it is look like a 192.168 dot something dot something, anything, no problem. Okay, same thing. It is an example. It's a hexadecimal number, right? So obviously anything, but all numbers must be hexadecimal numbers only. Okay, alternately 12 hexadecimals must be required. So 3. One more is there. Yeah. Okay, this is how IPv4 is look like, and IPv6 I didn't rate, but this is how IPv4 is look like. Okay, guys, we cannot change the MAC address. We can change the IP address, but we cannot change the MAC address. So this is the point. Guys, are you okay? So what is an IP address? Is a logical address. What is a MAC address? Physical address. MAC address is a unique address. IP address is not a unique address. We can change an IP address and based on the network. So every device in the network compulsory need an IP address. All communications by IP address, not with the MAC address. MAC address is a single version. It is 48-bit and 12 hexadecimal. IP address, we have IPv4, IPv6. IPv4 32-bit, IPv6 is 128-bit. So like that we can tell some differences. Okay, up to here. For last batch, before your batch, I typed everything personally. Okay. Once again with the hand typing is there. Now it is copy paste. Of course, I will do few things once again. Guys, in IP addresses, we have two versions. We already know we have a two versions. One is IPv4, another is IPv6. Here I'm going with the small differences, then I will explain about IPv4 and IPv6 differences. The first one is IPv4 is 32-bit, IPv6 is 128-bit. IPv4 2 to the power of 32 is a 4.3 billion IP addresses. This is the exact number of 2 to the power of 32. Okay, and in coming to the IPv6, it's 2 to the power of 128 means 3.4 billion billions of IP addresses. Okay, some people said it is some decillion, some number is there, undecillion something is there, 3.4 undecillion something is there. We don't know that much numbering system. Simply say 3.4 into 10 to the power of 38. It means 34 and 37 zeros. Write 34 and put 37 zeros, then tell me what is that number. Okay, so that many IPv6 addresses are there. Okay, IPv4, how many number of IPv4? Almost 4.3 billion IP addresses. It means billion means 100 crores. Billion means 100 crores. It means around 430 crores IP addresses we are getting, but here it is not a crores, it is more than that one. So 3.4 into 10 to the power of 38. It's a very big number of IP addresses we are getting. IPv4 is generally decimal format, IPv6 is hexadecimal format. IPv6 is hexadecimal format. Okay, so the next one is This is how IPv4 is look like, and this is how IPv6 is look like. Now I'm going to tell about few points about IPv4, guys. See, this is the IPv4 format is look like. If you see, this is the one part, second part, third part, fourth part. So your IPv4 is divided into four parts. Total bit is 32 bit and divided by 4. Each part is 8 bits. Each part is a 8 bit, means first one is 8 bit, second one is 8 bit, third one is 8 bit, fourth one is a 8 bit, which is separated by dot. The 8 bit number we call it as a octet. The 8 bit number we call it as a octet. 8 bit number we call it as a octet. Okay. So how many octets are there? 4 octets are there. We have a 4 octets. Okay. So total 8 bits. So then it is a 4 octets. Have a 4 octets in one single IPv4, which is separated by dot. Each octet size means octet means 8 bit, 2 to the power of 8 is a 256, 0 to 255 size. Okay, 256 means how you write a numbers, that is important. So I want to write 10 numbers. Decimal means 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is called 10 from 0. Same way 256, how to put it? 0 to 255. Okay, 0 to 255. So this is 256. Okay, so that is a each octet size is 255, meaning is it is in this area only we have a 255 part. Okay, this is a different part, guys. So that is a different part. Okay, so this is about how IPv4 structure is there. I will come back to that one. Simple, I want to explain 1 or 2 points about IPv6. I'm not adding anything. So we have a lot of points are there. The next one. Okay, but I'm not going to add anything. Just only explaining how IPv6 structure is there. IPv6 represented in hexadecimal format, guys. This is how IPv6 is look like. If you see one hexadecimal means, hexa means it is 0 to 9 and then A, B, C, D, E, F. So 0 to F. This is 0 to F. Totally 16 numbers are there. So 0 to F means this is equivalent to 15. Binary equivalent is 1, 1, 1, 1. So in single digit, one hexadecimal value, okay, single digit of hexadecimal value is 4 binary bits, maximum of 4 binary bits. If you take 2, 0, 0, 1, 0. 1, 0 is a 2 value, but in hexadecimal to 2, this is 0, 0 to 0, 0, 1, 0. You take a 6, 0, 1, 1, 0. You take 7, 0, 1, 1, 1, 8. Okay, this is 9, sorry, 8. A is 10. Okay, like this. So each number, even if you write a 0, it is 4 zeros. In binary, it is 4 0. Hexa 0, binary 4 zeros. and final like a F is the last digit. After this one, 1 0, 1 1, it will start like that. Like our 9, after 9 we got a 10, 11, 12. Same after F we are getting up to 1F. After 1F it is 2 0. Okay, so it is a 4 binary bits. Means one hexadecimal is equal to 4 binary bits. Okay. Now this is 128 bit. Means it is a 128 bit. 128 bit by 4. It is 32 hexadecimals are there. We have a 32 hexadecimals are there. Hexadecimals are there. Okay, each 4 hexadecimals. You take a 4 of hexadecimals and make it as a one block. Make it as a one block. Okay, each block is divided by colon. Each block is divided by colon. Each block is divided by colon. So it is a very big one, right? So that is what I'm trying to say. Okay, so here it is. It is a totally 32 hexadecimals are there. Out of 32 hexadecimals, we write in a 8 blocks. 32 hexadecimals we are getting. We write in a 8 blocks. Each block contains 4 hexadecimals. Each block contains 4 hexadecimals separated by colon. Okay, so that is what I am trying to say. This is our number. Okay, so different ways to write thing is there, guys. If you look at this example, this is 2001 colon A. This colon A represent in between these two digits to induce in between these two blocks. Entire remaining blocks are zeros only. Entire remaining blocks are zeros only. That is the way of writing this one. Okay. Next one is, if you have an IP address like this, if you have a IPv6 address like this, then you can write like this. See, it is 001, 01A0, and these three are a all are zeros. See, all leading zeros are removed. All leading zeros are removed, and now these three, one sequence, one set of 3 zeros are there now. Can you see one set of 3 zeros are become colon here. Like this also you can write about a IPv6. Okay. This is one part, guys. Second part is so how to write or how to not write kind of stuff also given. Okay, you can see this here it is 2 blocks are completely zeros. Here 3 blocks are completely zeros. So I make a 1 0 0 like this. Either you write like this or you will write like this only. Try to observe and you will get to understand. Okay. So this is the way of writing, but other few more things about IPv6 is there, but I'm searching why those things are missing here. Okay. So yeah, here it is. I've written. So here it is. Importantly say it is IPv6 and IPv4. There is a few more differences are there, guys. So we can write those things. So there is a global unicast address is there. That is called a 00 unicast address 001/3. This is the global unicast address. Okay. Meaning is, example, if you see anything like a starting 000 colon, okay, to starting one like a 3FF. This is completely global unicast. This is like a public IP address. It's like a public type IP address. Global unicast. Okay, this is first important, guys. Second one is link local. Link local IP address of IPv6 in generally in LAN it works. It's useful for LAN communication. Okay, it is FE80 colon. If anything started with a FE80, then it is a link local IP address. Works at LAN communication, not public LAN. It is a private IP. Okay. It's actually generated by system based on MAC address of .NIC. Okay. That is link local IP address. Okay. Not only this, there is a private IP address, multicast address, any cast address also there. Not only this, guys, there is a private IP address thing is also there. So I didn't remember that. So it is multicast address. Find out those things. Multicast. Private IP address, multicast address. One more last thing is that is called the unicast addressing. Is also there. This is by ISP. So ISP will take care of this one. It's okay, leave it. Okay, so this is basic points in IPv6, guys. So I'm going with the IPv4 once again. You guys understand at least a few differences. Okay, this is not much required, but read it once. It is important, but read it once. So then you will understand how IPv6 are look like and what is the meaning of it. And you should have interest to do that one. Okay. So these are the basic few differences, one or two differences between IPv4 and IPv6. Okay. Up to here, okay, guys.
Yes, sir.
Okay. Once again, I will go IPv4. It is 32-bit, 2 to the power of 32, 4.3 billion IP addresses. These are the many IP addresses we are getting from IPv4. It represents in decimal format. It is like this one. Okay. It is a 32-bit. It is divided into 4 parts. Each part is separated by dot. Okay. So each part is a 8-bit because 32/4 is 8-bit. So each part we call it as an octet. Each octet is 2 to the power of 8. Is a one octet size is 2 to the power of 8, 256. Means 0 to 255. Guys, this is a continuation of IPv4. Please check it. Okay, this is the continuation of IPv4. What is the octet size? Yeah, we can write from here, but it is take a lot of size. What is the one each octet size is like that, right? The first one octet is first octet. As for you, I will have putting IPv4 continue. First octet is first part is first octet. The second we call it as a second octet. The third one we call it as a third octet. And what is the fourth octet? Yes, of course, fourth octet is 4th octet only. Some people represent these things as a W, X, Y, and Z. Some people represent these octets, first octet as a W, second octet as a X, and a third octet as a Y, and the last fourth octet as a Z. Just for convenience purpose, and so certain textbooks also will tell like this, write an IP address. So it is for easy to purpose. So instead of telling first octet, second octet kind of stuff. Okay. So as I said, each octet size is 0 to 255. Okay. Each octet size is 0 to 255. Okay, either it can be 0, maximum of 255. Okay, actually your IP addresses range is 0 to 0, 0.0.0.0 to 255.255.255. So this is the last IP address in your range, or IP address IPv4 range, total IPv4 address range. These are the 4.3 billion IP addresses. The starting address is this, last address is this one. Actually, I want to go very simple, but I'm having a very bad habits, like a without explanation. I don't like it. So like just simply giving names, not right. So this is second IP address. First is 0.0.0, next one is 0.0.1, 0.0.2. It keep goes. Next one is 0.0.254. Once it is reached, then last one is 255. Not more than that one. After 255, there is no 256. 0.0.1.0. It is automatic. Like it's like a numbering system only. No differences. 1.1. One dot 254 0.0.0 2.0. Okay, so same thing, it is keep repeating 0.0.2.1. Okay, so sorry, this is sorry, I done a mistake. Just for our understanding, guys, it is keep goes like that only. If you take a pen and paper, if you start doing, and last once you are completed, you have to count it. You have to count. So it is around 4.3 billion, means that number will be satisfied. If you have a patience, write down all the IP addresses, everything, then you can try. So it is like that, it will happen. Okay. Look at guys, once it is completed, think like this is become 255.255. So what is the next one? 0.0.1.0. Like this it will happen. 0.1.0.1. Like this. Okay, so then it is also once it is completed, like like this. It will start like this again. It keep goes, guys, like a 1.255.255.255. Then it is become 2.0.0.0. Okay, so this is how 0.0.0.02 255.255.255. So this is the complete IP address range. So if from here to here, if you start writing one by one, you can count it. So the count number is equivalent to this number. So that is a total number of IP addresses. Okay. So guys understand up to here total IP address ranges. Total IP address is divided into 5 classes. Okay, 5 classes. Class A, Class B, Class C, Class D, Class E. We'll put it here. Okay, there is a binary numbering is also there, guys. So I'm not going to touch that one. Okay, the classes. Okay, I'm giving direct ranges, guys. So please check it. 128, sorry, 127, 128 to 191, 192 to 223. 224 to 239, so 240 to 255. Okay, here if you check in some Google search, certain websites, certain textbooks will show you 1 to 126. There is a story. I will tell. What is the story? We can't assign IP addresses to MIC. Okay, we can't assign these IP addresses. Look at this 0.0.0. This is a kind of unknown IP address. It is a this is called a unknown IP address. Okay, 0.0.0 is an unknown IP address, a reserved IP address for a static routing. Reserved IP address. DORA service. Okay, guys. Next one. So we don't use this entire 0 series. Okay. This entire 0 series, we don't use it. That's why certain textbook will tell start from 1. Second, we can't assign these IP addresses, 0 series IP addresses. So 127 series means, sorry, this entire 0 series, anything, you take any IP address like 0.1.2.3, we don't use, we can't assign to our NSC. Same thing goes for this 127.0.0.1. It is also reserved IP address. It is also reserved IP address for a local host or loopback IP address. Okay, loopback array local IP address. We use it for a self-testing, local service access. Local service access purpose, we use this 127.0.0.7, and we don't also use 127. Series, we don't use it. These are the reasons why these are all not using. This is, it is showing some textbooks showing like this, but original size is 0 to 127 only. And class E, it is R and D type. R and D. Okay, so class E is a R&D, means research and development kind of stuff. Certain places, certain reserved IP address used in some research are reserved for certain purposes, not using for a public.
Password combination password.
Multicast IP addresses. These are the multicast IP addresses for multicasting. Okay, used by some services. Services. Okay, for example, boot P, EIGRP. Example, just for example. Okay. Yes, remember class A, class B, class C are unicast IP addresses. Okay, guys, these are the ranges of classes. Okay, so to recognize IP address class, what to do? First, check the first octet. First octet. Okay. Or we can say W of IP address. Okay, to recognize IP address of a class, IP address classes, class. Check the first octet of IP address. Just look at here, and there is some IP addresses I've written. Please check it. Their classes. Okay, see it is 120. 120. Where is 120? Between 0 to 127. So it is a class A. Okay. Check, it is a 151. Where is 151? 128 to 191. It is class B. Check first octet. It's a 197. Where is 197? Between these two range. It is comes under class C. 120, 224. Where is 224? This is a class D IP address. Okay. 240. Where is 240? Is in between 240 to 255. It is class E. So again 170. Where is 170 comes under? Between this, right? So it is a class B. So like that we can able to recognize what is an IP address and which class it is. Recognize which class of IP address it is. Okay. Guys, understand how to check important things. Once again, I will tell guys. This part I will tell after a small break. Okay. Because you must remember a few things. I will tell once again. Guys, what are the things? What is an IP address? Okay. What is an IP address? What is the use of IP address? Difference between IP address and MAC address. Few differences between ipv4 and ipv6. 32, 128, decimal, hexadecimal, one or two things. Okay. Few more differences are there. I will tell that one also after some time. Yeah, that is here only I will cover. Okay. And what is an octet? So ipv4 structure is 4 octets with a separated with the dots. So maximum each octet size is 255. Maximum each octet size is 255. So remember that one. And our IP addresses, total IP addresses divided into 5 classes. And class C, class D, we don't use generally. We use class A, class B, class C only. Okay. And of course, this I1 we don't use it. Okay. Here I will put it. Here I will write here. IPv6. In IPv6, this 0.0 is represented in like this. Okay. In here also same thing. Okay. So these are we don't use this IP addresses generally. It's 127.0.0.1. It is a colon 1 in a IPv6. Okay. We can't assign these addresses and ranges to the any NICs. So 0.0.0.0 and entire 0 series we don't use it. 127.0.0.1 is a local host or loopback address. It is used for self-testing and local access purpose only. Local access purpose means system, same system, within the system. Means within the system means PC. Within the system or a computer, within the server, anything. Okay. And class A, class B, class C are unicast, which we are using. To recognize any class, first you have to check the first octet only. Okay, first octet. So see the octet and their ranges, compare this one, you can get it. Okay, so IP address, classes and ranges important. Okay, 127.0.0. What is 127.0.0.1? That is enough. Okay, that is important. Okay, and how to recognize the which class it is. So classes, ranges. What is this 127.0.0.1? And how to identify which class of IP address, the range of IP addresses. Okay, and then number of bits. Of course, this small information also important, guys. So now take a break. When we'll be back, 4:45 is okay.